on this 2010 to 2015 Honda Civic with the 1.8 gas engine. P16E3 is a PGM-FI battery sensor LIN communication error. In plain language, the PCM may not be seeing the battery sensor communicate correctly on the LIN line. The vehicle may have charging system or battery management behavior that feels intermittent, and the possible fault areas can include the battery sensor connection, sensor power feed, LIN wiring, the alternator side of the LIN circuit, or the PCM side of the circuit. Before getting deep into testing, start with the basic system checks, follow a structured diagnostic approach, and make sure the battery sensor terminals at the battery negative terminal are not loose. Start by verifying the problem. Turn the ignition switch to on Roman 2, or use the engine start-stop button to select on mode. Clear the DTC with the HDS, wait for 10 seconds, and then check for pending or confirmed DTCs with the HDS. If P16E3 comes right back, continue with the diagnostic path. If P16E3 is not indicated, treat it as an intermittent at this time. Check for poor connections or loose terminals at the alternator, battery sensor, and PCM. If captured data is available, try to reproduce the failure under those same conditions instead of guessing. Next, check the pending and confirmed codes again with the HDS. If the companion communication code is also present, the path goes toward the sensor power fuse and a LIN short check. If that companion code is not present, skip ahead to the battery sensor power feed check, and then the LIN open check. This keeps the diagnosis on the branch that matches what the car is actually reporting. With the ignition switch in lock 0, or the start-stop button in OFF mode, check fuse no. A1810A in the underhood fuse and relay box. If the fuse is OK, move on to the LIN short to ground check. If the fuse is not OK, repair the short in the +B horn wire between the battery sensor and the underhood fuse and relay box, and replace the no. A1810A fuse. Still in lock 0 or OFF mode, disconnect the alternator 1P connector. Check for continuity between alternator 1P connector no. 1. The YEL wire and body ground. If there is no continuity, the path moves to the LIN open check at the PCM and battery sensor. If there is continuity, keep going and isolate what is pulling the LIN line to ground. Jump the SCS line with the HDS. Continue checking continuity between the alternator 1P connector terminal and body ground while disconnecting the battery sensor 2P connector and PCM connector B, the 51P connector, one at a time. If continuity goes away when one of those connectors is disconnected, the LIN wire is OK, and the part on that branch is the one called out by the test. If continuity does not go away, repair the short in the LIN wire between the battery sensor, alternator, and PCM-B31. On the other branch, disconnect the battery sensor 2P connector. With the ignition in lock 0 or OFF mode, measure voltage between battery sensor 2P connector no. 1. The WHT wire and body ground. If battery voltage is present, the +B horn wire is OK, and the next check is the LIN line. If battery voltage is not present, repair the open in the +B horn wire between the battery sensor and the no. A1810A fuse in the underhood fuse and relay box, and also check the no. A1810A fuse. Jump the SCS line with the HDS. Disconnect PCM connector B, the 51P connector, with the battery sensor 2P connector disconnected. Check for continuity between PCM connector B no. 31. The YEL wire and battery sensor 2P connector no. 2. The GRN wire. If there is continuity, the LIN wire is OK, and the diagnostic path calls for replacing the battery sensor. If there is no continuity, repair the open in the LIN wire between the battery sensor and PCM-B31. If the earlier alternator LIN check sent you down this path, jump the SCS line with the HDS, disconnect the battery sensor 2P connector and PCM connector B, and check continuity between PCM connector B no. 31. the YEL wire and battery sensor 2P connector no. 2. The GRN wire. If there is no continuity, repair the open in the LIN wire between the battery sensor and PCM-B31. If there is continuity, the LIN wire is okay. Update the PCM if it does not have the latest software, or substitute a known good PCM. If P16E3 goes away after the PCM update, the troubleshooting is complete. If P16E3 goes away with the known good PCM substituted, replace the original PCM. Keep the final confirmation separate from the circuit testing. Use the same clear-and-recheck approach. Clear the DTC with the HDS, wait for 10 seconds and check pending and confirm DTCs again. The key with P16E3 is to let the code combination guide the branch, then prove power, prove the LIN line is not shorted or open, and only then make the sensor or PCM call that the test path supports. For more diagnostic training, visit stepdiagnostics.com.